So today we're just going to continue with SQL here, and then eventually move on to designing our own databases, because you're going to have to do that eventually. But we started out by looking at flat files, that they were not sufficient. And then we saw that an RDBMS solves many of the problems that you have with flat files. We went on to look at insertion, deletion, and update the CUD of SQL. And then we started on the retrieve, right? You can select all of the columns of all of the records of a table. You can select a subset only of those columns. Eventually, we got to aggregate functions, and you can do some data processing on the server itself, min, max, average, and then any math function actually. You can limit things using the where clause, right, and equality operators. You can have string matching and string like fuzzy string matching using the like clause. You can order things coming out in descending or ascending order and in multiple columns, right? Some observations about what we did last time. For example, if you do an update or a destroy without a where clause, then generally that will affect every row in the table, right? So you want to be careful. Generally, safe mode is going to save you from this. Later on, when you're doing stuff in Java, there is no safe mode. So you do have to be careful. But of course, if you're doing something in Java, you're going to have a backup of your database, like at least the mock data anyway. So you can always restore that. If you have a parent-child table, now remember, a parent-child relationship is a one-to-many relationship. So here's the publisher table. It's a parent. The game is a child. The availability is another child. So you actually have grandparent, parent, and then grandchild there if you want to look at it that way. But the parent must exist before you can have any child records. So insertion order matters, right? The child record must be deleted before the parent record can be deleted. So you need to go in the reverse order if you're deleting stuff. The parent has if the parent is the one, right, and the child is the many, and that forms a one-to-many relationship. So just think about, okay, well, I've got these two entities, these two ideas, and there's clearly a one-to-many relationship. So where should I locate the foreign key? In the child table, because the child always has the FK, the foreign key. As far as style goes, remember that you can break up long lines. You can use a beautifier if you wish. Beautifier if you wish. We're not going to make you go that far, as long as you're consistent about it, right? And then also you can use the modern lowercase convention for SQL keywords, right? Save your pinky so you're not typing so much. Okay. All right, so what I want to do now is something a little bit more complex, and that's going to require a little bit of math background, right? Math. All of SQL is based on set theory, right? So you might have done sets before, I don't know, but I'll give you a reminder here that if A is in the set A, right, where A is equal to, and then we use square brackets to denote a set, right? A, B, and C, right? So this notation right here says that A is in the set A. And A right here consists of the elements A, B, and C, right? So this is true, right? We can also say that, X is not in A, right? So where have we seen this before? Well, we saw it before when we were playing around with SQL. Let's go up to my examples here at the very end, right? Where you want to search for a game with an ID of 3, 7, or 13, right? You can use in and parentheses, just like you could with like the set notation here, okay? And instead of square brackets, you have parentheses. That allows you to do the subquery here, so that you can get an entire collection, and then as long as the game ID is in that collection, right? And that's the set theory right there. We'll eventually do Cartesian products, but let's see. What about projections in math? Let me indent both of those. Right? What about projections in math? So let's think about this geographically or geometrically, right? So geometrically, I'm just going to pull out a picture here eventually. Now, if I took a three-dimensional cube and then I projected it down onto two-dimensional space, what would it look like? A square, right? Because a three-dimensional cube gets projected down. If it's perfectly projected, of course, if it's at an angle or something, it might be a little bit different. But here it is, right? You're losing a dimension. You're going from 3 dimensions down to 2 dimensions. In other words, one of those dimensions gets squashed, okay? You can do that with data too, right? So again, you suppose that you have a 3-dimensional cube and you project it down on a 2-dimensional plane. You get a square, right? What does that look like mathematically? You're just taking something with 3 coordinates, say x, y, and z, right? And you are projecting it down onto 2, let's go right arrow here, right? And you are projecting it down. Why are you not, here, now can you do, okay, whatever. Right arrow, x, y. Why are you not, there we go, now it's rendering, right? It just needed to figure it out. So you're taking x, y, and z, and then you're projecting it down onto x, y. You're taking away one of those dimensions. You're crushing one of those dimensions. Now, why would that help us with respect to data? Let's look at an example. And for that, I need to zoom in here because I don't want to see it all at once. Suppose that we had the following table, right? It's a bunch of books, okay? We have the title, the author, and in our library, we have a number of copies of that book, okay? So 3 dimensions, right? 3 columns. What I want to do is I want to determine how many copies of each author do we have. For example, Norman Mailer here, we've got The Naked and the Dead and The Barbary Shore, right? And one has 10 copies and the other has 3 copies for a total of 13 copies of Norman Mailer books. Likewise with Douglas Adams, we have 3 books, but there are 4, 2, and 1, so that's going to be 7 copies total. And then Orson Scott Card, we have 1 book with 7 copies. I want a report that says 13, 7, and 7, ordered by the author, okay? Or grouped by the author is what we're going to be doing, okay? So step 1, you group them by the authors. We're going to put all the Norman Mailer books together. We're going to put all the Douglas Adams books together, and we're going to put all the Orson Scott Card books together. Then we are going to project this 3-dimensional thing down onto 2 dimensions, losing one of those dimensions. In particular, we don't care about the title anymore. We just care about the author and then a sum of the number of copies. We want something that looks like this, okay? So that's what we're ultimately doing. We're taking 3 dimensions, we're squishing it down and losing one of those dimensions, but we're gaining something else. We're gaining new information over here, okay? And I want to do that over here in our database. In particular, let's go ahead and look at this game table, just the game table for now. I want to know how many games are published by each publisher. How many games are published by each publisher. Right? So I'm just going to involve myself with the game here. If I just select all the games, select everything from game, right? Then I'm going to get a list that looks like this. Right? It's not ordered in any way. Right? If I were to order it, say by publisher ID, or group it by publisher ID, then I'll have all of the 1s together, all of the 5s together, all of the 6s together, the 8s together, etc. Right? Then I want to crush it down on one dimension. I don't care what the names of the games are, I just want a count of the number of games. Okay? So how do we do that? We do that with a group by statement. So use group by to aggregate projected data. Right? So select everything for now. I'm just going to select everything from game, group by publisher ID, because that is what I want to answer. How many games are published by each publisher? By each, for each. Group, that's your key word to understand that you should be grouping by that group. Right? I'm not going to group by the game ID, because what if I grouped it by the game ID? It's already grouped by the game ID. It's unique, right? So I would get like 1, 1, 1, 1, 1 out of that entire thing, right? Now I'm going to execute this, but it's not going to give me what I want yet. Right? It's going to give me unique publisher IDs, because what I've done is I've grouped them by their publisher IDs, and then I've collapsed them down. I've projected them down onto the plane, losing one of those dimensions, right? But I haven't gained that data that I wanted. What I want instead is a publisher ID, and then a count of all of the records that have been grouped by that publisher ID. Right? Let's go ahead and execute that and see what we get. So publisher ID 1, there are 3 games published by that that publisher. 5, there are 5. 6, there are 4, et cetera, et cetera. Look at the name of that column, count star. That's a perfect use case for giving it an alias as number of titles. There we go. Now, there's a problem here. In fact, there are a couple of problems. The first problem that I would notice is, does this mysterious internal number here, this key, tell me who those publishers are? Does it tell me that that one is LucasArts and that one is Nintendo? And I just have that memorized by now, right? No, it doesn't have enough information there. Why? Because where's the name of the publisher? It's over here in the publisher table, right? All right, so was my design bad? Should I have combined those two things? Well, kind of like class design, if it's a game thing, where does it belong? In the game table. If it's a publisher thing, where does it belong? In the publisher table. That's called normalization. There's first normal form, second normal form, and third normal form. And we'll go over all of those. But you need to separate things out into separate tables in a relational database system, right? All right, so I don't have enough information to determine who these publishers are. What else do you see over here? I see 1, 1, 1, 2, 2, 3, 5, 5, right? Et cetera, right? So I don't see any publishers that have no games, 0 games, right? I want that in my report. I want to know, are there any publishers who have published 0 games according to this database? So 2 problems already. Before we get there though, you can actually, let's go ahead and add another one here. You can filter results after a projection using having, right? You cannot use a where clause. All right, so let's try first of all. So select everything. For example, I want only the publishers with the number of titles greater than 2, right? Where number of titles is greater than 2. Right? If I try to execute that, of course, it's not even going to work because it's bad syntax. Let me break that up into multiple lines here. And go to the next line there, just so that we can read it all. Okay? Where? That's because wheres are filtered before projections. If you've got data up here in a higher dimension, you can filter it out, but then you're projecting it down into a lower dimension, you can't filter it out with the same keyword. So what I'm going to do is I'm going to change this into a having, right? And now it's perfectly fine, right? Now we don't have all of those with a single game, right? It has 3 games, 5 games, or 4 games, right? Because it was strictly greater than 2, okay? Let me go ahead and restore the original as well. I guess that was the original up there. I don't need to copy that. There we go. You can still use a combination though. You can still use a combination. So for example, if I wanted both a where clause and a having clause, from game group by, I can put a where clause, but it has to be at the appropriate place. Where publisher ID is greater than 2, group by publisher ID having number of titles greater than 2. And now we're only down to 2 results instead of the 3 results before, because I think you're now excluding Nintendo or whatever, right? Okay. So select from where to filter those results, then you can group by, then you can use a having to filter the projected data. Right? Okay. All right, what about now we need to bring multiple tables together, right? Dot, 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 okay? And for that, we're going to need a little bit more math, okay? So suppose that you have 2 sets, right? Have we all seen set theory before, at least this set notation of using curly brackets and ABC and 1, 2, 3s and stuff like that? Okay, right? So suppose you have two sets like that. The Cartesian product, or the cross product, is defined as follows. It's going to be A times B, right? We use the times symbol here. And then it's going to be all pairs, A, B, such that A is in A and B is in B. This wedge is just an and, right? So have you seen that too in logic? Okay. All right, good. So this is the Cartesian product. Now give me those 2 sets up there, ABC and 1, 2, 3. What is that set? Give me some elements that are in that set. Oops, there we go. So what should I start with here? A1, right? And then A is paired with 2. And then B is paired with 1. And then B is paired with 2. Right? And then C is paired with 1. And C is paired with 2. Right? Okay? Note here that we're using parentheses to denote what are called tuples, pairs. Those are ordered pairs. A1 is not the same thing as 1A. Right? But in a set like this, ABC, that's the same as BCA or CBA or any combination thereof, right? Because sets are unordered things. These are tuples. They are ordered because we're using parentheses there. All right, well, how big was it? Right? So the cardinality of A, have you seen that before? If you put brackets around the vertical lines around it, that's the cardinality, the size of a set. That was 3, right? What was the cardinality of B? 2. So therefore, what was the cardinality of A? Cross times B. There we go. Is equal to? 6. Right? Or generally, what? Generally, if, say, you've got A has n elements and B has n elements, or m elements, let's say, right? Then how big is A times or cross B? How big is that? NC dot M, right? N times M, right? All right, where have you seen this before? Cartesian, where have you seen that term before? Cartesian coordinates, Cartesian plane, where you've got x comma y, right? Let me put that in a math mode. And that's in the set what? Math BBR times math BBR. What does that R stand for? All real numbers. The real numbers cross the real numbers. What is that? It's the Cartesian plane, right? These are Cartesian coordinates or plane. Right? In other words, you've been dealing with that since grade school. Right? X comma y is a tuple. It's a pair. And it is a cross product, right? Or this is called a cross product or a Cartesian product of two things. Now, don't think of these as numbers. Think of them as tables. Right? What I want to do is I want to cross the table game with the publisher in order to combine them together. Okay? Now let me just do that blindly. Okay? We call this join, right? So select everything from, let's go with game first. How many are in there? 20 it looks like to me. Let's go ahead and do a count instead. How many are in the game? 20, okay. So let me put that into to a size 20. Select count of everything from publisher. And how big is that? How big is the publisher table? 15, right? So there are 15 elements in there, okay? So if I just did a cross join, a blind cross join, right? Then it's going to be select everything from game, join, publisher, okay? Now let's just go ahead and execute that. And I'm going to get a whole bunch of stuff. Does it make much sense though that GTA 6 was published by LucasArts? And GTA 6 was also published by Sony and Square Enix and. None of that makes sense to me, right? But let's go ahead and count these. What's your prediction? How many things were actually in there? 15 times 20 is 300? Yeah. Why? 15 cross 20, just like our A and B sets. A cross B, the cardinality is going to be multiplied together. This is a small database, right? 300 elements, or 20 times 15, that's nothing. A real database is going to have millions of elements, tens of millions of elements, billions of elements. What if this was 20 million and this was 15 million? Right? How many are going to be in there now? Not 300 million. 300 quintillion probably, actually, right? I don't know, is that, right? Wolfram Alpha, because millions times millions is quintillions, right? So 20, come on, 20 million times 15 million. Hopefully you're interpreting those M's as millions. Okay, no, minutes. All right, so million times 15 million. Give me a name for that. Yep, 300. Oh, that's 300 trillion. All right, sorry. I heard billions, and I said quintillions, but it was only trillions, right? So is 300 trillion things coming out of your database anytime soon? Probably not, right? So let me restore that back to actually what it is. So we do not want a blind cross join. It is way too big. It makes no sense, right? It is not following our relations in the tables, right? How is a game related to a publisher? A game is published by a particular publisher. In other words, if the publisher ID of the game matches the publisher ID of the publisher, right? So let's winnow that down, right? So I'm not going to do a blind join anymore. I'm going to do a join based on a foreign key equaling a primary key. Remember, FK is foreign key equaling a primary key. Right? So select everything from game, join publisher on game.publisher ID is equal to publisher.publisher ID. Okay? So this on clause is telling me how you should join them. You shouldn't just join GTA to LucasArts and GTA to Sony and GTA to Nintendo, right? You should only join GTA to Rockstar Games, the actual publisher, because those publisher IDs in the game table and the publisher ID in the publisher table match. Let's see the results now. I am only getting 20 results now, one for each game, and I'm matching them with their one parent because there is a child and a one parent relationship there. So all the GTA games are published by Rockstar Games. Right? All of the Nintendo games are right there. The Capcom, Eidos, etc. Nintendo is there again, etc., etc., etc. Right? So there's a join. Right? Now this is done so often. You do this so often that you can use shorthand for it. So select everything from game, G. I'm just going to give it an alias. You can do something like this actually, as G. Join publisher as P on, and then you don't have to go game dot, you can just go G dot publisher ID is equal to P dot publisher ID, right? So there's a shorthand way of doing it. In fact, you can make it even shorter. This is so common that you can actually omit the as keyword entirely. Right? There, now we're down to, that's the minimum, you can't go any further, right? All right. You can also do this on a where clause, but that's weird. Why are you doing that? It's explicitly a join. Just use the on keyword there. Can you remove the on keyword? Let's find out. No, you have to have something there, right? Okay. All right, well, that's actually what's called a left join. A join, a join is an outer join, I think it is. An outer join, right? It will join only on the values that are matched, right? Now for game to publisher, the values are guaranteed to exist. Why is that? Because that's how we designed our database. This is a child. A child cannot exist without a parent. So they're always going to have this publisher ID. Otherwise, the record wouldn't exist. Now, what about going from the other way? What about going from the publisher to the game? Right? So order matters. Order matters. Let's go ahead and go the opposite direction here. What if I were to select everything from publisher P, then join game G on P.publisher ID is equal to G.publisher ID. Publisher ID. Okay. I'm going to get 20 results here. Let me go ahead and sort them. Oh, they're already sorted according to the game ID it looks like there. So I'm going to get the exact same results as before, but I see that there are missing publishers here. Right? Let's go ahead and look at all the publishers. Select all the from publisher. For example, A, B, C, and D, E, F. Those are ones that we put in there the other day, or maybe I did it in another section, right? Namco, Atari, Blizzard Entertainment. I didn't see them anywhere in the other one, right? In this result right here. Do you see Blizzard anywhere there represented? Nope. So it doesn't preserve records. A normal join does not preserve records in table A to table B. Okay? What we need is a different type of join. We need a left join. A left join does. A left join, and I'll put that all into quotes there. A left join preserves records in table A joined to table B that do not have any matching records in table B. All right? Publishers. They don't have any matching records to a game in table B. Publishers are A, games are B. Right? So let's take a look at the difference here when I add a left to that. Exact same thing as before, but now it's a left join. Right? So select everything from the publisher, but if the publisher exists and does not have any corresponding children, we're still going to preserve that record. Let's see the difference now. Do you see Sony, Square Enix, Sega, Blizzard, Atari? Right? They're now preserved, but were there any records in the game table that they matched? Nope. Therefore, what values can it put in there for you? Nulls. Right? There's nothing there. This is also visualized over here. I've got another example here. All right, here's another example. So if I've got a student table and an email table, clearly we have a one-to-many relationship because one student can have many emails. All right? For example, Ryan Sandberg has 2 different emails there. Rizzo only has 1 email, and then Starlin Castro, identified by student ID 1234, right? Number 13 at the Cubs, right? There's only 1 there, okay? By the way, do you see Dale Sweem over here? Does he have any emails? His student ID is 1122. Is there any student ID over here with that? Nope. So in a regular old join, Castro, Rizzo, and Sandberg times 2 are going to be joined to the address table over, or the email address table over there. But with a left join, right, then you end up preserving that Dale Sweem record. But of course he doesn't have any email, so it ends up being null. That's the difference. Now you might be asking yourself, well, why is it left, right? It's because we're going from table A in this case. This is table A, and this is table B. Records are preserved left to right, from table A to table B. You might be asking yourself, is there a right join? And yes, right? It's just going the opposite direction. So let me go ahead and grab our other one over, our original one where we started at the game table. Right? Now, if I start at the game table and I do a left join, it's no different. Because I start from the game table, that's table A, going to table B, it's going to preserve records left to right. I'm not getting any of those publishers that have no games. But if I say that it's a right join, then it will preserve. It'll read backwards for you. It'll preserve values from the right table to the left table. Right? I can't have left-right join. Sorry, there we go. Right join. And there we go. Now Sony Entertainment, Square Enix, Sega, now they are still preserved over here. Right? So should you use a right join? Generally prefer left joins. Why? Because English speakers read left to right. Right? Are you jazzed about the idea of reading right to left? No, I don't like that. Sometimes you have to, and I'll show you an example here towards the end of where you actually have to go both ways. Okay? All right, so there's a left outer join, right outer join. And it's basically nothing more than a Cartesian product. I don't want to go over any more math, but maybe. So a relation, a binary relation between two sets, A and B, is a subset of the Cartesian product. So here I'm not going to use math bulb, I'm going to use R instead. R is a subset of A times B. Something like that. Have you seen that before? Right? This subset notation here. Have you seen relations before? In a discrete math course? No? Well, a relation is just a subset of the Cartesian product that satisfies something, right? For example, let's say x and y are in R, and then let's go with if and only if x is less than or equal to y. Come on, you can do it. There we go. There. There's a relation. It's a common relation. You know what this relation is. X is less than or equal to y, right? They're related. So 5 is related to 10. 5 is related to 5. But is 5 related to 3? Nope, because it is not less than or equal to, right? So that would not be in this set. So you can look at this as a diagonal line on the real number line, and then you're looking at everything above it, right? Okay, that's a relation. Now do we understand why we call these relational database management systems? It's because it's nothing more than him taking a couple 100-year-old math and writing programs around that, the mathematical idea of taking a Cartesian product of two tables and then providing a relation. This is the relation, right? Instead of x is less than or equal to y, then it's, well, that value has to equal that value over there, right? And it's all relations, okay? All right, so let's see. I don't want to design, I don't want to go over there yet, just yet. Okay, so let's go back and solve that other problem, right? Solve the original problem. We want to know how many games has each publisher published, but we also want to know the publisher, and include all publishers with 0 games. Those are the two problems that I identified before, right? So let's go ahead and start out by selecting everything from publisher, P, join game G on p.publisher_id is equal to g.publisher_id. Right? All right, so there's my start. That's what I had before. But am I what I want to do now is I want to group them, because what I want to do is I want to group them by their publisher ID and then project them down so that I don't get 1, 1, 1. I get that LucasArts has produced 3 games, published 3 games. Right? So we'll add on to that. Oops. So we'll add on to that. Group by, can I do this? Publisher ID. Right? Let me try first. It won't work. Right? How many publisher IDs do you see here at this point? I see 1 and 2. Which one do you want to group by? Right? Got to choose one. I don't know, p.publisher ID. It doesn't matter because they're both equal, right? There we go. Now, I've got them grouped by that. I don't have an aggregate yet. So what I want is I want the publisher name followed by a count of all of the values. That's what we did before. There's still a problem. What do you mean by name? Column name in the field is ambiguous. I would never have designed it like this to begin with, like in real life. I would have put like game title or something here, and then publisher, I would have kept that one as name. But now we've got 2 fields called name. Which one do you want? Right? All you have to do is preface it with the table's alias, p.name. Right? There, LucasArts has produced 3. Nintendo has produced or published 5. Delphine Software has produced 1. Right? Let's go ahead and do the same trick as we did before, as number of titles. Right? That's much better because it's not just this mysterious count star. I still have not solved the last problem though. I want to include all the publishers with 0 games. I'm just doing a regular old join here. Is that going to preserve the publishers with no matching records? Nope, so let's do a left join. Still not there, right? Okay. Why does A, B, C, and D, E, F have 1 here? Well, you might think, oh, okay, well, it must just be off by 1. Let's go ahead and subtract 1. Right? But now LucasArts has produced 2 games, is that correct? There. No, there were 3 before. You can't just do that math. So that's not the solution. Right. What am I counting? Let's come back up here to the actual left join over here. I end up counting rows. Sony Computer Entertainment, excuse me, right? How many rows do you see with Sony Entertainment Computing Entertainment? 1. That's why I'm getting the 1. I don't want to count rows. What do you want to count? So that these 3 things will be counted, but this thing right here will not be. I'm going to count the game ID, right? So let's count not the rows, but g.gameid. That solves my problem. Now, Sony Entertainment has 0, Square Enix has 0, etc., etc., etc. The reason that this works is when this becomes null, it doesn't get counted in your count. If you have 5 and then you add null, it won't affect it. It will be like 5 plus 0. Right? So when you sum, when you average, when you count, nulls are ignored. Right? And it's got to be the game ID because everything else might not be null. I mean, you could do the name, but generally what you would want to do is something unique. And that's always going to be the primary key. Right? So count the primary key and you're good. Right? All right, good, got that. And let's go ahead and do one last thing, and then we'll go into do some more exercises, as much as you want. You can think of some exercises too. Let's go ahead and go back to the beginning. Right. Flatten the entire data model. Data model, so you can dump it to a CSV. Right. This is one of the most common things you can do, right? Because you're going to take you're already taken CSV files and made them into JSON and XML EDI. One other aspect of EDI is taking your CSV files and eventually you're going to want to put them in your database. And guess what? There's a CSV to JSON.com. There's a CSV to XML.com. Guess what else there is? A CSV to SQL.com, right? So you can take your CSV files and you can actually produce a bunch of SQL. What I want to do is I want to go back to the beginning though. I want to take all of this data, this entire data model, and I want to flatten it out into one CSV file, one flat file. So let's start over here at the publisher, then go over to the game, then go over to the availability, then go over to the platform to see what they're available on. All right? So that's going to be a big query. Select everything initially, from publisher P, join game G, and here I'll put it on one line, p.publisher ID is equal to g.publisher ID. Right? Join to the availability, join availability A on g.publish or g.game ID is equal to a.game ID. Right? Just have this over here, right? We're going from the game table, game ID, to game ID over here. Now to go from the availability table over here to the platform table, we would join the platform ID onto the platform ID. Right? So join platform P on a.platform ID is equal to p.platform ID. Does anybody see any problems immediately? Look at all my aliases. What are they? P, G, A, P. I reused the same alias twice. Right? So I'm going to have to use plat there instead. Plat. Or just platform. Whoa, I don't know what that was. Anyway, there we go. I've successfully flattened the data model. Careful. Do you see what Sony Entertainment represented here? Let's go ahead and sort by them. I see Rockstar that goes to Valve. Do you see S? Nope. So what should we have done here? A left join, right? And then also a left join, and also a left join, right? Why? Because if I only did a left join from table A to table B, but not from table B to table C, they get cut out at that point. And I still don't have Sony Entertainment. I have to do a left join all the way over. Left join, left join. Right? And now I've got Sony Entertainment, but they've been joined to nothing because they have no games, and no games means no availability on any platform. Right? All right, what are the unique platforms here? I see Game Boy, Mac, NES, PC, PlayStation 1, 2, and 3, Super Nintendo, Xbox, and Xbox 360. We never actually looked at the platform table, did we? Select star from platform. All right. I see all of those are there. All right, so let's go ahead and add one because this is a rather old list. Let's go ahead and insert into platform, name, values, switch to. That's coming out soon. There we go. And also maybe, I don't know, an index. Anybody play VR stuff? No? Okay. Not much game players at all? No? All right. So let's go ahead and put in switch, and let's go ahead and put in index. And you know what? What was that? It's a little game with a crank. It's like a specialty hardware a portable game. I got it for myself, and then I gave it to my kids, and the novelty wore off really quick with a crank. What was it called? Playdate, there it is. So there's this little Playdate, and what you can do with it is, well, there's this little crank on the side, so you can crank. It was like not a GoFundMe, but it was whatever they call it. You know, they looked for capital, and then they built it. And I got one because you can. They've got a C library that you can build games, and I thought I'd do something with it, but I never did. $200, wow, I wasted that money. Anyway, come on, show us the crank. You're not gonna show us the crank. Fast forward. Yeah. There's the crank. So some of the games are actually pretty good. Because it's a different mechanic, but it's more of a retro kind of game. Again, the novelty went out really quick. But let's go ahead and add a play date here. Play date. There we go. All right. So I know that there are 3 platforms in there that don't have any games in my database yet. Let's go ahead and execute this command again. Do you see playdate or the index or that other one that I just switched to represented over here? Because where was I reading? Left to right. Right? Here's an instance in which you would want to preserve from right to left. Right? So I could rewrite this entire thing and then reverse it, go from the platform table to the availability, to the game, to the publisher. Or I could go ahead and grab it all and say right preserve, right? Right join, right join, right join. And now I'm going to get playdate. Where is it? There we go. There's switch to, there's playdate, and there's index. And those are now preserved from the right because you're reading right to left. That's still not satisfying because what happened from my left angle, right? From the left side. Do you see, I don't know why it's not doing well here, but whatever. Do you see Sony again? Sony's now missing again. I've got this set and I've got this set. What I want to do is I want to combine them. More math. Right? So basic set operations. What if I have A, cup B? What is that? That's the union, right? The union of 2 sets, right? No duplicates. Right? But that is all elements in A and all elements in B into one set. What's the other basic one? The opposite of that, cap. That's intersection. Right? elements in both sets. And I told you, it's all based on set theory. So let's go ahead and take this set and combine them using union. Right? So this will be a set. This will be a set. Note that I got rid of the semicolon here because I want to union them together. There. Finally, a flat data model. Where Sony Entertainment is preserved from the left, Playdate, Switch, and Index are preserved from the right. If you were to dump this to a CSV file, you'd either use the keyword null or you'd use an empty token or something like that. It depends on how you want to store it. But you can actually export it if you want as a CSV, right? It comes up all the time. Right? And so let's see, can I open this? Open with Atom, I guess. And open a new window so I can show it to you. Come on, all right, fine. There it is. All right. And it saved it as a CSV file, so it's going to be a bunch of quotation marks there, unless the quotation marks are not needed. It's preserving the spaces there, apparently. And then it is using null, 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 null. Okay. So move that back over here. Okay. You could also probably export it as other things as what? Oh, hey, as JSON, as XML, as TSV, right? These are the as SQL insert statements, right? So a whole bunch of, or CSV, but that's, what is that, semicolon? Why would it be CSV? It'd be semicolon S. SSV? Semicolon separated value? I don't know why they call it CSV. Separated with the semicolon is what I assume that means. Or you can an Excel spreadsheet, right, et cetera, et cetera. These data models are pretty much universal. JSON, XML, CSV, SQL. Those are the ones you're always going to be dealing with your entire life. Okay? All right. And I grew up with XML, and then JSON was introduced when I was in my professional life at one point, and wow, this is much better. Let's start using this. And it was much better because it was much shorter and much easier to understand. But anyway, all right, where everything is still built on it. Maybe some exercises. ... Let's go ahead and clear this out. I've got as many exercises as you want to do. We've got, or we can cut it short. But here are all my exercises. Some of them are probably repeats of what we just did. But this is what you're going to be doing in your lab next week. But not on this database, on an albums database. Right? So list all the video games in the database. Help me out. You help me out. Select what? If you don't care, I want everything. Star, from, game. Was it game or games? I forget. Game, why? It's the game table, not the games table. The contents of the table are the games. The table itself is the game table. Never pluralize a class, never pluralize a table, right? Good. And also, what else do you see about my naming conventions over here? Right? What about all of the columns? Publish year, platform ID, et cetera, et cetera. They're all lower camel case, just like Java variables. What about all of the table names? Now here I would argue a different way of doing this. I would argue that it should be the game table, and the publisher table, and the availability table. Why would I argue for that for being more modern? It's going to be the exactly. We follow the exact same conventions as our classes. So there's a one-to-one correspondence. When we design our tables starting next week, we're going to design a database from scratch, right? There's pretty much going to be, okay, if that's an object over there, that probably is a table, right? And that'll inform your design, right? So if you use all the same conventions in your tables and your classes, you don't have to remember anything, right? What about those primary keys? They're all named after the table that they're in, slapped on with an ID after it. What about the foreign keys that map back to a primary key? Exact same names. Right? Following these conventions, you will never have to remember anything like that. Right? If I followed the same convention, was it game or games? I never pluralized things, so it must have been game. Right? List all the video games that start with G. How did that? We did that already. Right? So select everything from game, and we don't use a where clause. We use a like clause, where name like, and then G, and then what was our magic placeholder here for anything? Percent sign. There we go. So GTA. That was the example we did last time. List all the publishers in the database. Select star from publisher. I should have updated this. These are all the things we already did. List all the video games along with their publishers. That's going to require a join. We did that already. List all the video games along with their publishers, but only the relevant fields. All right, that's nice. Select everything from publisher, P, join. And do I need to do a left join here if I start at the publisher? A parent always exists for the child, so you don't need to. Right? I'll show you that there's going to be no difference. Join game G on. You can go to the next line on. P dot publisher ID is equal to G dot publisher ID. Remember, foreign key matches primary key, so I didn't even have to look up the schema. But only the relevant ones. And what we mean by that is, look at this. Publisher ID is repeated here and here, right? Let's get rid of that repetition. Also, do we really care about the game ID? We only care about the name and the name, right? So let's just grab the name and the name, except that there are two names here. There's the publisher name and the game name. That'll give us what we want, but again, there's a name. Which one is which? So let's give it a alias as publisher and as title. There, publisher and title. That's what I would want to see on a report as a human, right? I don't want to see this name, which one is which, especially if I don't know anything about the data. Along with their games, even if they don't have any, right? So that'll be a left join there, because that'll get me Sony, Sega, Square Enix with no games there, right? List all the publishers with a count of how many games they have. We already did that. List all the games on all the systems that they're available on. There we go. Well, we already did that too. Oldest game, we did that. Flatten the entire data model. I did all these things already. Insert a new game though. Assassin's Creed, published by Ubisoft. So that's a reminder of what we did on Tuesday. Insert into game, name and publisher ID. Right? Values. And I did this Assassin's Creed because remember, what are your strings? Single quotes. What are we going to have to do that single quote in the title itself? Escape it. Backslash. Right? And then whatever the publisher ID is of Ubisoft. So I'm going to have to insert into Ubisoft first. Insert into publisher, name, values, Ubisoft. Oh, and then here's another trick. If you want to insert multiple records all at once, Ubisoft, Microsoft, and Macrosoft. There was a Macrosoft. I remember them. Right? They specifically named themselves as a joke. Right? So let's go ahead and insert all three of those things together. Did it work? Come on. Didn't work, it looks like. Why not? Come back up here. Column count didn't match. It should have. Why can't you do that? Values. There's a way to do this. Why is it not working? I think I know. So unfortunately, you have to surround everything with parentheses here. Not that parenthesis, but there we go. All right, there we go. So you can insert multiple records at once if you want to. Right? Otherwise, insert into Assassin's Creed. Now, I'd have to look up what Ubisoft's publisher ID is, or I can use a subquery here. Select publisher ID from publisher where name equal to Ubisoft. There. And not enough parentheses. There. And now Assassin's Creed is in there. The only reason I did that was to remind you that you can escape stuff. Make the new game available on at least 2 platforms. Let's make it available on Playdate and Index, right? So insert into, give myself some more room here, availability, right? So what am I going to need for the availability table here? The game ID and the platform ID, and I should put in the publish year. So insert into availability, game ID, publisher ID, and publish year, values, and then we'll say, I don't know what the game ID is, I don't know what the publisher ID is. We'll say that it was published in 2025, right, on the index. Right? So select game ID from game where name is equal to Assassin's Creed, and select publisher, or not publisher ID, what is it? Platform ID. So select the platform ID from platform where name is equal to playdate. Playdate. There we go. All right. Oops. Execute. There we go. And then I'm going to just cut and paste because I want it available on 2 systems, so let's make it available on Index, the VR system. There we go. Now, to ensure that that worked, I'm going to come back all the way up here to where I've flattened the entire data model, right? This union, and let's see if it worked. So there's Macrosoft. Okay, where's Assassin's Creed? There we go. Ubisoft, Assassin's Creed, available on the Playdate and the Index in 2025.
So it doesn't matter where you put the union, like flat.
No, I could have put this one first and then this one second.
And it doesn't even matter where in your, in your code that you put that, as long as it's in the code.
Yeah, I'm only executing one command at a time here. So I went up and I executed this one query. Okay. And it's one big giant query because it starts on line, whatever that is, and it ends down there. Right? Okay. So I'm only ever executing one query. If you want to execute the entire thing, then it would be Shift Command Enter. You usually do that with when you're like creating the database and inserting test records or whatever. But this entire time I've only been doing one at a time. Okay. And the difference there is these 2 buttons up here. Execute the entire thing or execute what you're currently on. Right? All right. Update and delete. We've already done those. All right, so any questions? Otherwise, we're going to get more practice next week by revisiting our accounts. Remember, we did a stock account and an annuity account. We made an inheritance hierarchy for those things. Let's go ahead and make a database for those things now. Right? And then we'll start with that, and then of course you'll get more practice in Lab 7 by doing basically a lot of these same exercises, but on an albums database instead. Right. All right, so I'll see you upstairs if you are choosing to go to the lab. Otherwise, I'll see you next week.